Usually, thankfully, for those of you that don't work in microbiology, for the most part, you usually don't have to deal with stool specimens because micro has those mini hoods and stuff. So I know when I worked, I used to be one of the people, I used to gripe all the time because they wanted, for whatever reason, I worked in hematology a lot. And they wanted hematology to do one of the tests we're going to talk about today is an occult blood. It's really, really simple, but if you have to make the occult blood, that means you have to open the stool specimen, and we didn't have any hoods out there. So the lab would smell bad for a few minutes, you know. And I used to always say, oh, they did this back in micro where they got hoods, and they can work under the hood doing this instead of us, you know, making the lab smell horrible. Do they do the occult bloods in micro at National Park or wherever the places you've been?
I think that one they do. The only place that really smell bad was.
Yeah. Well, for the most part, I think that you encounter stool specimens will be back in micro, which is where it should be. Simply because, I mean, I've seen them in micro before. Those hoods, they really do work. You guys will see that when you go to clinicals. I've seen them. There's a test they do in micro it's a serology test called rotavirus. You guys ever heard of that? And a lot of times they'll bring in a baby's diaper. And it's cool if it's your own baby, right? But it ain't cool if it's somebody else's baby. And you'll open that diaper and it's, oh God, it's horrible. I mean, it's bad. I mean, there's a reason they're ordering a rotavirus test. And there's nothing, I think, that smells worse than a baby's diaper. That's not your own kid. Okay. But I've seen them open them up under the hoods, and you can't smell anything. I mean, it's crazy. It's like you got a diaper in front of you and you don't smell anything. So, just kind of telling you this story so you know, use those ventilation hoods back in micro if you ever have to deal with a stool specimen. Like, you know, even if you're working in chemistry or hematology and for whatever reason you do that particular test in that department, your microbiology department should not care if you go back there and do the test under their ventilated hood, all right? So anyway, fecal analysis. There's quite a bit to this chapter. I looked at the exam a while ago. There's 5 questions on your exam from this chapter. I'll try to point you in the right direction. We've got to first off talk a little bit about the A&P, the anatomy and physiology of the digestive tract, just so we can kind of determine what produces this stool. You know, what determines whether you produce a lot of stool, a little stool, if you're constipated, or if it's a major watery stool. I'll tell you from my experience, most of the stools that you test for in the lab are like diarrhea, because that's what brought them to the doctor in the first place, is there was something going on with the stool specimens. So you will see the worst of the worst. I'm not going to sugarcoat it. It's kind of rare to see a normal stool specimen, no matter what test they're doing usually. All right, so some of you, if I go a little too fast today, we've got a lot going on. Basically, I'm going to be answering the objectives, okay? It's in front of the chapter, and I definitely will make sure that you highlight areas that I think that you may see in something. All right, so under the physiology on page 256, on page 256 in the left-hand column, it says the normal fecal specimen contains, of course, bacteria, cellulose, undigested foods, GI secretions, bile pigments, cells from the intestinal walls, and it contains electrolytes and water. You'll skip a sentence. It says one of the things that cause the smell of fecal specimens is bacteria. It says bacterial metabolism produces the strong odor associated with feces and intestinal gas. All right, next paragraph in the right-hand column, it says digestion of ingested proteins, carbs, and fats takes place through the alimentary tract. The small intestine is the primary site for the final breakdown and reabsorption of foods and compounds. Then it goes on to say digestive enzymes secreted into the small intestines by the pancreas include trypsin, chymotrypsin, aminopeptidase, and lipase. Now, we've talked about the pancreas in another chapter about it secreting certain digestive enzymes, all right? So if your pancreas isn't working, right, that can be a reason important that you have certain types of diarrhea, and we can classify it by that. So they can actually look at stuff going on in your stool and make a pretty good guess about, you know what, we need to look at this person's pancreas, because we've got all kinds of fats and things in the stool that obviously the pancreas is not secreting those enzymes in order to break those foodstuffs down, all right? Okay, this picture at the bottom of the page. Stay with me in the reading, go down about 5 lines. I'll give you a second to find this because it's important. It starts with as shown in figure 14, tac 1. Everybody with me? It says, as shown in figure 14, tac 1, approximately 9 liters of ingested fluid, saliva, gastric, liver, pancreatic, and intestinal secretions enter the digestive tract each day. Under normal conditions, only about 500 to 1,500 mils of this fluid actually reach the large intestine. Okay, the rest is obviously absorbed in the small intestine. Then it goes on to say, and only about 150 milliliters of this fluid is actually excreted in the feces. So in this picture, you can see that a normal person takes in about 2 liters of food and drink. Now, I'm not in the reading now, I'm just looking at the picture, but you can see there's a lot of secretions and fluid and foods that are taken in through the body, and most of it is going to be absorbed in the small intestine. But once we get to the large intestine, you've still got a lot of water. Okay, the large intestine is like the final little tube, right, that all the food and the water's in before you're going to have a bowel movement, okay, and get rid of this. All right, first sentence on top of page 257 is important. It says the large intestine is capable of absorbing approximately 3,000 milliliters of water. So when it gets down to the large intestine, where all that's left is the actual bowel movement itself, after that, the large intestine is where the maximum amount of reabsorption of water is going to take place. Now this is important because we've got to differentiate, like, what's causing diarrhea? I mean, if you think about it, what is diarrhea? Just a bunch of water in the stool, right? Okay, well, if you've got more than that 3 liters of water that reaches the large intestine, that kind of breaks that threshold, right? So if you have more than 3 liters of water, obviously you got to get rid of that water, and it's going to be through your bowel movement. So that's going to be one reason you can have diarrhea. Now what we're going to do is we're going to break it down and talk about different types of diarrhea. Okay? There's a diarrhea called osmotic diarrhea. There's a diarrhea called secretory diarrhea. And then there's also a diarrhea, which is the one that most common people that don't take courses like this think about. It's called altered motility. I mean, if you ever went to a restaurant and you know what I mean, you eat something and all of a sudden you get sick at your stomach, and it's like the stuff you ate ends up being excreted out of your body in about 2 hours, all right? That's more along the lines of altered motility. They've got words that go with that, like I think the book calls it rapid dumping syndrome, rapid gastric emptying syndrome, and all of that. But that's where, for some reason, whatever you took in, the digestive tract in your body, it's kind of it's touchy-feely, all right, and it doesn't like what's going through there, and so instead of going through the normal process where reabsorption and all that stuff takes place, it goes straight through the body. And if it does that, it's got to have a lot of water, okay, also to push it out, and that's called altered motility. The stuff you're going to be dealing with back in microbiology and things like that is the book really concentrates you being able to tell the difference between osmotic diarrhea and secretory diarrhea. One of them has to do with maldigestion and malabsorption, and then the other one has to do with you got some sort of a parasite or a protozoan infection. You guys in microbiology, I'm sure you've heard of things like Salmonella and Shigella, SS auger. You always set up, or I used to have to, you always set up an SS auger on all stool specimens of micro, all right? Because you're checking, that's one of the biggies that can cause diarrhea is Salmonella and Shigella. Okay, what's another one that you always hear about that can cause diarrhea? E. coli, all right? There's another thing that even you'll hear a lot of, traveler's diarrhea, for example, okay? All right, Page 257, under diarrhea and steatorrhea, it says diarrhea is defined as an increase in daily stool weight above 200 grams. You have increased liquidity of stools and frequency of more than 3 times per day. That means you'll have more than 3 bowel movements a day. And then it tells you, if you'll skip a sentence, it says diarrhea lasting less than 4 weeks is considered acute diarrhea. If it lasts more than 4 weeks, this will be considered chronic diarrhea. All right, so it does have, there's one sentence right above that green word secretory diarrhea in that column. Go up and it says that electrolytes are increased in secretory diarrhea and will be negligible in osmotic diarrhea. Now that's important when we distinguish the two, because believe it or not, there is a test that they do on stool specimens called fecal electrolytes. And one of them is sodium, okay? And sometimes they also do potassium. You know, those are one of the few ones that actually can be done in the chemistry department, right? Okay, let's talk about secretory diarrhea. Left-hand column on page 257. It says this diarrhea is caused by increased secretion of water. It says bacterial, viral, and protozoan infections produce increased secretion of water and electrolytes. This will override, which is what I was talking about earlier, the reabsorptive ability of the large intestine, leading to secretory diarrhea. Enterotoxins producing organisms such as E. coli, Vibrio, Clostridium. You'll hear when you work in the lab of Clostridium difficile. There's those two again, Salmonella and Shigella. It also mentions Staph, Campylobacter, protozoans, and parasites such as Cryptosporidium can stimulate these water and electrolyte secretions. It also says other causes of secretory diarrhea can be drugs that you take, laxatives, certain conditions like inflammatory bowel disease, Crohn's disease, ulcerative colitis. So there's lots of different things. There's another word you need to know also, diverticulitis. You'll hear that. Any of you ever heard that word before?
Oh, yeah.
That causes problems as well. All right, so that's secretory diarrhea. Basically, I try to think of secretory diarrhea as basically, this is having to do with organisms, viruses, again, parasites for the most part that cause this type of diarrhea. Now, the next one that we're going to move on to is called osmotic diarrhea. This just has to do with people that are having problem digesting what they eat, okay? Doesn't necessarily come from a bacteria that's causing it. This is going to be people, somebody that's got pancreatic problems, right? If you have pancreatic problems, you're not producing those enzymes, it's not breaking down the stool, so you're going to end up having diarrhea that way. 2 words go with osmotic diarrhea: maldigestion and malabsorption, right? All right, osmotic diarrhea, 257 right-hand column. It says this is caused by poor absorption that exerts an osmotic pressure across the intestinal mucosa. This will cause incomplete breakdown or reabsorption of foods present, increased fecal material to the large intestine, which will result in water and electrolyte retention in the large intestine. This in turn results in excessive watery stools. Maldigestion, malabsorption contribute to osmotic diarrhea. Now there are other things that can cause osmotic diarrhea. I think your objective in the front of the chapter says list 3 things that can cause secretory diarrhea and 3 things that can cause osmotic diarrhea. I've already listed 2 that can cause osmotic, okay, malabsorption and maldigestion. But it tells you in this column, it says causes of osmotic diarrhea include disaccharide deficiencies or lactose intolerance, poorly absorbed sugars, and then there's other things, laxatives, taking too many antacids, amediasis, and antibiotic administration. I know some of you have probably heard of that's a side effect of taking antibiotics, is it'll give you diarrhea as well. Really good study guides, table 14, tac 1, and table 14, tac 2. Those are good study guides. As we finish the chapter, these will make more sense to you about tests that are done to differentiate secretory from osmotic diarrhea. Okay, altered motility. You guys can read this on your own. I don't think that I've got anything on the test about this, but it's just another type, or it's another reason or another cause of diarrhea. This is the one where I was telling you about, like the rapid gastric emptying and rapid dumping syndrome, to where basically the food just goes through your body too quick. All right, steatorrhea, left-hand column toward the bottom. The detection of steatorrhea, which means fecal fat in the stool, is useful in diagnosing pancreatic insufficiency and small bowel disorders that cause malabsorption. Now, if you really think about this, I mean, this kind of sounds gross, but whatever will help this make sense to us. If you eat certain foods, your body has things like the liver and the gallbladder and the pancreas that all contribute. Remember that duodenum in the small intestine where I just tell you things squirt out? There are certain secretions that are going to cause the food to be broken down and to be reabsorbed, okay? So if there's anything wrong with that stuff, like if, let's say a person has cystic fibrosis, right? We know cystic fibrosis is caused from the pancreas. Remember those 3 diseases of the pancreas we talked about? What did we say they were? We said they were
Pancreatitis.
Okay, what else?
Pancreatic cancer.
Cystic fibrosis.
Okay, so those are the 3 things. So you can bet all 3 of those disease processes probably will cause there to be increased fats in the stool, all right? Now, believe it or not, there's certain things, I mean, I always thought this was kind of neat. You might think it's gross, but you can tell when there's certain fats in the stools because there's something called like meat fibers or muscle fibers that you'll see. And there's a whole section of this chapter that talks about it, but I think right now is a good time to kind of bring it up. But I want you to think about something. I used to always think of a fiber as a leaf. Like, let's just say you eat a vegetable. Now, I'm telling you this kind of wrong, but I'm trying to help it to where you don't have to memorize it and it'll make sense. Let's say that you eat a leaf, okay, or a fiber. And let's say under the microscope it looks like this, okay? And let's say that leaf, you ever looked at a leaf and there's little lines on it or there's striations? Mm-hmm. So let's say when you eat a leaf, okay, this is what the leaf looks like before it goes through your body. It's got these striations. And it's got horizontal and vertical striations. Okay, in other words, this is a meat fiber or a muscle fiber. Before digestion takes place in the body, it's got the striations, okay? So, if you see this in the stool, you want it to look like this. See what I mean? It's like it's been digested, so these striations go away. In other words, there's been a process take place to where the body utilized this muscle fiber, and so now there's no striations, all right? So this would be a digested muscle fiber, and this would be an undigested muscle fiber. So I kind of think of it as if you eat the leaf and it goes right through your body and the striations are still there in the stool, we can see it in the stool, okay? We can take that stool and add a drop of saline or a drop of water and kind of mix it up, make it liquid, and put a cover slip on it, and you can see these fibers. And what you do is you have to put it through a chemical process, but just one of the things you're looking for is whether or not these striations exist. If the striations are there, obviously you didn't digest that muscle fiber or that meat fiber. If the striations are not there, that's a good thing. This is what you want to see. That means the patient is digesting the food they eat.
Okay.
All right, we're still on steatorrhea on page 258, the left-hand column. I'm about 5 or 6 lines up from the very bottom of the left-hand column. It says that steatorrhea may be present in both maldigestion and malabsorption conditions. And there is a test that can distinguish those two called the D-xylose test. D-xylose is a sugar that they actually give you, okay? This is not something that your body produces on its own. This is something that they're gonna put into your body, and what they do is it goes through your body and it says it's a sugar that does not need to be digested, but does need to be absorbed to be present in the urine. So it says if the urine D-xylose is low, that obviously means that you have a malabsorption problem, right? If it's normal, it means that you're gonna have a maldigestion problem. So a D-xylose test is something that can differentiate malabsorption from maldigestion. Okay, specimen collection. When I was looking over this morning, I thought about that answer's an objective. There is gonna be a test question that comes from that reading about specimen collections, but I'm gonna tell you what you need to know about it, okay? Depending on what lab you work in, now, I may differ a little bit from the reading, but I'm telling you real world stuff about it now. Usually stool specimens are sent down, I call them like in a butter bowl, all right? They'll either be in a gray container, they usually won't be see-through, okay? The ones I've got made up for you today are see-through, because I want you to get used to seeing stool specimens, all right? But they usually come in a little bowl. Usually they have to be walked down to the lab. Remember I told you that in most labs now, they have pneumatic tube systems that tube all the specimens? Well, you can imagine if you tube a stool specimen, right? And you'll get these little smart aleck nurses and people that wanna play jokes and stuff that'll always turn them over on the lid. That means when you open it up, it's like right there staring at you, okay? So if you just wanna make sure that they're upright and that they haven't been turned over, because you don't wanna take the lid off. The book is gonna tell you they come in screw top lids. I've never seen them in screw top lids. I've always seen them like in a butter, like where you take the lid off that way. They claim screw top lids. You wanna be very cautious when you're opening that lid. Now, I'm talking about just a qualitative stool specimen where it's just a random stool specimen. You just always wanna be careful, take the lid off, kind of hold it away from you because things happen, okay? When you have a stool specimen in a closed container, there is a gas that builds up and a pressure, all right? I'm not trying to be gross, but I'm just telling you, I'm helping you out here, okay? So you don't wanna like have that real close to you when you open it, all right? Because sometimes it'll kind of, all right? And you don't want that to happen. So always use common sense when you're opening them, all right? And if you ever have to take one out of the pneumatic tube system, I would call whoever tubed it and say, why did you just stool this? Why did you just send this through the pneumatic tube system? In most situations, they have to walk down stool specimens, all right? And that's just for some of the more common tests, like we're gonna talk about a fecal occult blood. There's a test on stool that you just need a random sample. Rotavirus is one. What else is there? Fecal WBCs. A lot of times you'll see a test come down called a fecal WBC. There's a test they do in micro for Clostridium difficile. That's a big one. That's just some more of the common things. Now, I didn't see very many of these. I maybe saw 3 or 4 of them down, but there is a test. If a physician thinks that somebody truly does have this condition, steatorrhea, all right, they want a quantitative stool specimen brought to the lab. Quantitative stool specimens have to be collected over a 72-hour period or 3 days, right? And so, for whatever reason, they like to ask those questions on registries. They skip all the stuff that I think you see every day, but they say, how long does it take to collect a quantitative stool specimen? It's gonna be 3 days, right? And you don't wanna be the one that has to process that specimen, right? Because usually, now this book doesn't really say it like some of the older books has, but a lot of times patients are instructed to collect those in paint cans. Have I told you guys this story already? All right, well anyway, the reason they collect them in paint cans is because some of the tests that they have to do when they're doing a 72-hour fecal fat or a test that detects steatorrhea is they have to homogenize it. And that means they take that stool and they put it on a paint shaker and they shake it all up and they try to like break it down as much as they can, all right? Oh, so if you ever see a patient walk into the lab and say, who am I supposed to give this to? And they're holding a paint can, you can bet it's not blood in there or it's not urine, it's fecal matter. Hopefully it's a send out test like it was where I worked and you don't have to open it, alright? But you never know, one of you guys may go to work at a reference lab where guess what? You're the lucky one that gets all the quantitative fecal specimens sent from all over the country, you know? But in most places it's a reference test if they do quantitative fecal analysis because physicians they don't order that test as often as they do some of the other things that we're gonna talk about today.
I think the worst thing ever would be if the lid wasn't on it all the way and you put it in the shaker. Because that's happened like at the Walmart I work with paint. And it goes everywhere, all over the inside of that. So if the top,
Well, hopefully you won't be the one opening the lid.
so you're the one, it's like, I gotta make sure this is on all the way.
Okay, under specimen collection, just so you have this highlighted for a study guide, go down to the last paragraph under specimen collection, and that's where the important part you need to know. It says for quantitative testing, such as fecal fats, time specimens are required because of the variability of the bowel habits and the transit time required for food to pass through the digestive tract. The most representative sample is a 3-day collection. That's the important part, 3-day collection. Okay, so let's talk about the macroscopic screening of stool specimens. Let's talk about, this is what brings the patient to the doctor to begin with. We all know that normal stool specimen is gonna be the color of a brown color, all right? But stools can change colors, and this can be pathogenic. It can be something that really needs to be seen about from a physician, or it can be non-pathogenic. It can be from maybe drugs that you're taking, foods that you're eating, and things like that can make the stool change colors. There's a good chart, a study guide, table 14, tab 3, on page 259 that lists all the colors and the different appearances, but I'm gonna go through the reading for you to talk about what causes some of these colors. I'm under the color, the last paragraph on page 258. It says the brown color of feces results from intestinal oxidation of stercobilinogen to urobilin. Now, if you'll remember, we've talked about this before. Remember, the red blood cell breaks down to hemoglobin. The hemoglobin breaks down into bilirubin. And then the bilirubin, once it gets to the liver, all right, it breaks down to urobilinogen. And then urobilinogen from intestinal bacteria can break down into something called urobilin. And urobilin is what I want you to remember is what gives stool that brown color. Urobilin. All right, so that's the normal stuff. So it goes on to talk about if you have a stool that appears pale, I'm in like the last 3 lines on page 258. It says stools that appear pale may signify a blockage of the bile duct. Pale stools are also associated with diagnostic procedures that use barium sulfate. And all of this stuff I'm telling you about is in this blue box as well. Okay, top of page 259. It says a primary concern is the presence of blood in a stool specimen. Depending on the area of the intestinal tract from where the bleeding is happening at, the color can range from bright red to dark red to black. Okay? It says blood that originates in the esophagus, the stomach, or the duodenum takes about 3 days to appear in the stool. During that time, a degradation of hemoglobin produces a characteristic black tarry stool. So stools that are black or tarry looking, they actually contain blood, but it's blood that originated high up in the digestive tract, so it's not gonna look like what you would think blood would look like, okay? It's gonna be black. It says likewise, blood from the lower GI tract requires less time to appear and retains the original red color. Green stools, next paragraph says green stools may be observed in patients taking oral antibiotics because of the oxidation of fecal bilirubin to biliverdin. All right, if we look at this chart down here, just so again, let's go through these real quick. Black is from upper GI bleeding or from the upper digestive tract. But again, it says iron therapy or charcoal or bismuth antacids. These are also things that would be non-pathogenic that could cause your stool to be black. Red, gonna be lower GI bleeding, but your stool can also be red from eating beets, anything that contains a food coloring of redness. And there's a drug called rifampin. I didn't know what this was for, but I looked it up. That's a drug used to treat tuberculosis. One thing I want you to add there, because you will see this often, is that your stool also can be red because you got a hemorrhoid, all right? And I only bring that up because that's so common. So just for your knowledge, just because you got a hemorrhoid, your stool could be red, but it's usually gonna be red on the outside of the stool specimen. And that's one reason that, as we talk about later, when we do an occult blood test, again, this is kind of gross, but I'm just making it make sense to you. You don't ever want to pick some of the stool from the outer edge of the stool, because hemorrhoids are going to cause there to be blood on the very outer edge of the stool. So it's, I don't know any nice way to put this, you kind of got to dig in the middle of the stool when you're checking for true blood in the stool, all right? Because hemorrhoid, that's not really significant. That's just going to be something, but they're not worried about hemorrhoid. They're more worried about something that is causing blood in the stool. Okay. I don't think that's worth noting. I think it says that somewhere in this chapter, but not in this area. Okay, under the appearance, it says that if you'll go down to the last couple of lines in the left-hand column on page 259, it says that slender, ribbon-like stools suggest obstruction of the normal passage of material through the intestine. Goes on in the next column, it says the presence of mucus-coated stools indicates intestinal inflammation or irritation. It tells you at the very bottom of that paragraph, now I never knew about this, but it says the presence of mucus should be reported. So we never had to call that, but I guess at some places, if you think that you're seeing mucus in the stool, that you're supposed to call that to the forefront. And that has to do with dysentery, invasive, mucosal pathogens that can cause that. Okay, one of the tests they'll do on just a random stool specimen is they want to know if there's leukocytes in the stool. Okay, we all know what leukocytes are, white blood cells, right? So there are times, I used to do this I used to have to do this test all the time in the lab, but if they send that stool specimen down, a lot of times it'll say they want occult blood, they want fecal WBCs, and they'll also say that they want to know if there's any fats in the stool, to where you look for these fibers and things like that. They also sometimes can test for, they'll use a stain that we're going to talk about, where they're seeing that there's cholesterol or triglycerides in the stool specimen as well. So let's cover these fecal leukocytes. 59, right-hand column. It says white blood cells, primarily neutrophils, are seen in the fecal specimens in conditions that affect the intestinal mucosa, such as ulcerative colitis and bacterial dysentery. Microscopic screening is performed as a preliminary test to determine whether the diarrhea is being caused by an invasive bacterial pathogen, such as Salmonella, Shigella, Campylobacter, Yersinia, or E. coli. It says bacteria that cause diarrhea by toxin production, such as staph and Vibrio, or viruses and parasites, usually do not cause the appearance of fecal leukocytes. It says, therefore, the presence or absence of fecal neutrophils can provide the physician with diagnostic information before receiving the culture report. So this gives them an idea of what kind of organism or pathogen that they're looking at. Next paragraph says specimens can be examined as wet preps stained with methylene blue, or as dried smears stained with Wright's or Graham stain. Now, we never did this, so this is something that's a little bit new to me. We always actually looked at a wet prep because our procedure manual said take a little bit of the stool specimen and add like a drop of water to the microscope slide and mix it up with a stick. We looked at it as a wet prep, and we actually would see the white blood cells. But now when you do that, you can't tell whether that white blood cell is a seg, is a lymph, you don't know. It just appears like the white blood cell I showed you guys on the urine sediment, all right? But there are ways, I guess, where they make a certain stain where it'll identify the white blood cells. Now, I have been to some clinical sites and I have seen them, but in order to do that, you've got to let the stool, of course, dry, right? You can't have it wet and then try to put a stain on it, it won't work. And so you got to let it dry. So I saw some people that'll make a light stool smear and then they put it on a right stainer. The same thing where you see the white blood cells on those differentials. All right, toward the end of that paragraph, it says that in an examination of preparations under high power, as few as 3 neutrophils per high power field can be indicative of invasive conditions. If you're looking at it under oil immersion, the finding of any neutrophil, that's per field, has an approximately 70% sensitivity for the presence of invasive bacteria. So it's very important if you see that white blood cell or not under oil immersion. All right, muscle fibers. Very last couple of lines on page 259, going into page 260. If you were asked to view the stool specimen for the presence of muscle fibers, on page 260, I'm just going to tell you the major important points about this. There is a procedure that you're supposed to use to emulsify the stool, and like this chemical called eosin. But what I want you to know about muscle fibers, go down about exactly halfway in the left-hand column on page 260. It says undigested fibers have visible striations running both vertically and horizontally. And then skip a sentence. Tells you only undigested fibers are counted and the presence of more than 10 is reported as increased. Now see, if you're seeing undigested muscle fibers, again, it means that the body is not digesting fats, all right? So you'll see those striations going both ways. They have pictures of these there's 2 pictures of muscle fibers on page 260. They kind of show you what these muscle fibers look like. You know, I tried to do research about these muscles. There is very little information out there because I wanted to see better pictures of these striations to maybe at least tell you guys about. We had an old book that was probably 30 years old where I worked at, and there was, because we didn't get this test ordered a lot, so if I was working and I had to look for muscle fibers, I just wasn't sure what they looked like. So I would go to this reference book that had a black and white picture, believe it or not, of it was a hand drawing. Somebody drew it. And that's all I had to go by. So I'll just be honest, I never called it a muscle fiber. I never said that I saw undigested muscle fibers because I wasn't really sure about what they look like because there's not many reference guides for it.
In the book, it says that the patient should be instructed to eat red meat.
Yes.
What do vegetarians do?
I don't know what vegetarians do on that, but yeah, we're going to talk about that because a lot of these tests, when you're doing fecal analysis, you're supposed to eat red meat, and some of the tests, like for occult blood, you're not supposed to eat any meat because when you eat meat, meat has blood in it, and because of that, it could test positive just based on your diet. So that's a good question. I don't know. But yeah, some of these tests we're talking about, the patient is instructed to eat so much red meat. I don't know what you're gonna do there.
Stay healthy.
All right, there you go. All right. You don't have to, just talking about that, you don't have to do these tests everything. I mean, I went to a physician the other day and the guy was mad at me because I refused to do about 3 or 4 things they wanted.
What do they want to do?
Stuff that I don't want to go through, colonoscopies, and all that good stuff. I'm like, no, let's not do that.
I'm quite proof on that.
There's another test that I want to talk that's not in your book today that is starting to. I'm not saying it's replacing a colonoscopy, but have you guys seen that commercial called the Cologuard? Did I tell you all that story?
Yeah.
All right. Well, that's a test that uses DNA to look at the stool, and I did a bunch of research when I got here this morning on it to tell you guys about it, but the Cologuard test, and some of you guys could have did your paper on this, or maybe do your paper when you go on UAMS on this. But they look at the stool specimen and they can do DNA of the actual cells that are, like cancer cells that are replicating. It has nothing to do with genetics or like anything like that, like you're prone to get it. It is an actual test where they can look at the stool, they can look at the DNA and tell if there was some cells that were shed into the stool from maybe a precancerous lesion or a cancer lesion. And they've had really, really good results. I think they said they did a study of 10,000 people and they found the cancer in 92% of the cases. And that everyone that they said was negative was correct 87% of the time. But that tells me 13% of the people had colon cancer and that test did not tell them it was positive. Okay, you remember us talking about the difference between sensitivity and specificity? 13% in my eyes is not a good number.
No.
It needs to be less than that.
It needs to be like 2%.
But anyway, just type in Cologuard, it'll tell you all about it, all about this new test, and it's been FDA approved, but it's not as invasive as a colonoscopy.
Right.
Okay? So that's what drives some people to it. All right, qualitative fecal fats on page 260, left-hand column. Toward the bottom, it says specimens from suspected cases of steatorrhea, remember that means fats in the stool, can be screened microscopically for the presence of excess fecal fat or steatorrhea. So when you read over this, there's gonna be a procedure that you can do to where you can add certain chemicals. One of those chemicals that I want you to remember the name of, and it's in your reading, is called Sudan 3. Anytime you see this word, if you see Sudan something, 2, 3, whatever, if you see the word Sudan 3, I always want you to associate this with they're testing for some sort of fat, okay? Sudan 3. There's another one, I don't know if the book will call it, but it's called oil red O.
Yeah, it's in there.
Is that in there?
Yeah.
Okay. These two stains are for fats in the stool, all right? Basically, I'm not gonna test you on how you do the test. I just want you to associate these words with fats in the stool. If you add Sudan 3 to a stool specimen, now it's probably gonna tell you to heat it and all that, I'm not worried about that. But if you add it and you see these orange-red droplets, those are considered triglycerides, okay? There's a picture of it in your book on the next page where you'll see all those little orange circles. Those are like triglycerides. They represent triglycerides. I think the book tells you in the reading if you see, I don't know, more than 60 or something like that, that's considered positive. That's called excess, you're seeing excess triglycerides. If there is cholesterol, all right, the book is gonna tell you about, you can possibly see cholesterol. All I want you to remember about that, you remember what cholesterol crystals look like, right? Remember those boxes with the notched edges or whatever, they just kind of, something like that. So I want you to think triglycerides, your book is gonna make it confusing because they're gonna call it neutral fats, okay? They're not gonna call it, they may have in parentheses, neutral fats means triglycerides, but I want you to think Sudan 3 or oil red O will test for triglycerides or what they're calling neutral fats. But as far as cholesterol, you should be able to see the cholesterol crystals if you put it through the little chemical process. Now those orange boxes that you see on page 260 and 261, those are the procedures to do some of these tests that we're talking about. But again, I'm not going to test you on those procedures because what will you have at your clinical site if they have you do this test?
Procedure manual?
Yeah, you'll have a procedure manual, and that procedure manual will step you through it step by step. Some of the things you won't have to use the procedure manual for because you do it every day. But there'll be some tests that are not ordered very often that you'll see even techs that have been working there 20 years. They'll have that procedure manual open. You'll know right away that's a test that's not done very often if they're having to look at the procedure. Okay, occult blood, chemical testing of feces, the top of the right-hand column on 261. Very first sentence is important. Make sure you have it highlighted. By far, the most frequently performed fecal analysis is the detection of occult blood. Occult means hidden blood in the stool. You'll drop down about 8 lines. It says, annual testing for occult blood has a high positive predictive value for detecting colorectal cancer in the early stages and is recommended by the American Cancer Society, particularly for people older than age 50. Now, something in between that I just read, I just want you to understand, is having less than 2.5 milliliters of blood per 150 grams of stool is normal. So we all have a little bit of blood in our stool, okay? That's normal. The test that we're gonna talk about, it actually has to be governed in a way to where it doesn't pick up small amounts of blood because else everybody would test positive, okay? So it only picks up if there's considered more than 2.5 grams per 150 grams of stool, or 2.5 milliliters, I'm sorry, of blood. Okay, so let's talk about this test. What we're gonna do in lab today, it's a real simple test, but it's called a guac test for the presence of fecal occult blood. It says the most frequently used screening test for fecal blood is the guac-based test for occult blood based on detecting, make sure you have this highlighted, the pseudoperoxidase activity of hemoglobin. Pseudoperoxidase activity of hemoglobin. So if you look at the reaction down just below this paragraph, it says if there is hemoglobin in the stool and you mix the hemoglobin with hydrogen peroxide along with the addition of a guac paper, this guac paper will be on the occult blood card that you're using. You got guac paper, you're using hydrogen peroxide, all you do is add 2 drops. If there is a significant amount of hemoglobin or blood in the stool, all right, it's going to yield, or it's going to be oxidized, and it's going to produce a blue-gray color. It's real easy to see this, okay? I've got 3 samples in there for you to test today, and hopefully you'll see a positive and what negative looks like. Yeah, there.
If we see blue, then we should assume that there is more than 2.5 milliliters per 150 grams.
Yep, bingo. Yep. And guess what? These cards even have controls on them. They got 2 little circles where the manufacturer of the cards actually have one of the circles that should test positive for blood and one negative for blood. So you have to, when we do it, I'll show you, add 2 drops to each little square pad that's got stool underneath it, and then you add 1 drop right in between the 2 controls, and you'll be able to tell this is positive, this is negative. And now you look at the squares just above it and just see if it matches your positive control. All right. Trust me, when you guys do it, you don't have to do but 1 or 2, and you'll be a pro at it. Okay, go down to the reading underneath that reaction. It says several different indicator chromogens have been used to detect occult blood. All react in the same chemical manner, but vary in their sensitivity. Remember, you want something that's not real sensitive because you don't want everybody to be positive, right? You only want to pick up the people that have more than the 2.5 mils of blood per 150 grams. It says, contrary to most chemical testing, the least sensitive reagent, which is the guac reagent, is preferred for routine testing. Considering that a normal stool can contain up to 2.5 mils of blood, a less sensitive chemical reaction is understandably more desirable. In addition, pseudoperoxidase activity is present from hemoglobin and myoglobin in ingested meat and fish, certain vegetables and fruits, and some intestinal bacteria. It says, therefore, to prevent false positive reactions, test sensitivity must be decreased, which can be accomplished by varying amounts of the purity of the guac reagent used in the test. Okay, on page 262. thing I want you to make sure you have underlined, because they seem to ask this on the registry every once in a while. Trying to figure out how to get you to this. Okay, first full paragraph, go down about 11 lines, 11 or 12 lines. I'm at the end of a line, but it says 2 samples from 3 different stools should be tested before a negative result is confirmed. Now, I'll say that again slow, make sure that you find that. 2 samples from 3 different stools should be tested before a negative result is confirmed. And you know, if you have to do this test at home, they can actually have you take the kit home with you. They want you to do this from 3 different samples, 3 different bowel movements, okay? And then they want you to actually, if they have you make the card yourself, you have to basically go in with a little stick and take it from 2 different spots on the stool specimen. I think you guys will feel better about this after we do lab today, and you'll understand it a little better.
I understand it.
Okay, it does say that there are different tests to detect occult blood. They have an immunochemical fecal occult blood test that basically uses an immunochemical using an anti-human hemoglobin antibody. Okay, believe it or not, they can develop antibodies that will detect hemoglobin. All right, that's not the test we'll be doing today, but it will detect occult blood. They even have a test at the bottom of page 262 that is porphyrin-based, a porphyrin-based fecal occult blood test. Okay, quantitative fecal fat testing. Right-hand column on 262 says quantitative fecal fat analysis is used as a confirmatory test for fats in the stool or steatorrhea. Then remember, as discussed, quantitative fecal analysis requires the collection of at least a 3-day specimen. And then this is what Patricia was talking about. The patient must maintain a regulated intake of fat before and during the collection period. I think it says they want you to take 100 grams per day. That box, I don't think this is on the test, guys, but just for your interest, that box at the bottom of page 262 tells you things that can cause false positives and false negatives for occult blood. All right, page 263, the APT test, or if you're trying to determine, okay, this is done on newborns and they're trying to figure out, is this blood truly from the baby or is this blood possibly from the mom? I think you guys probably covered this a little bit in blood bank, but it's a test for fetal hemoglobin, right? Page 263, right-hand column says, grossly bloody stools and vomit are sometimes seen in neonates as a result of swallowing maternal blood during delivery. Should it be necessary to distinguish between the presence of fetal blood or maternal blood in an infant's stool or vomit, there is a test called an APT test that may be requested. It says the material is emulsified in water to release the hemoglobin. You guys remember what happens when you add water to blood, right? It lyses. It says after centrifugation, there is a substance called sodium hydroxide is added to the pink hemoglobin containing supernatant. If it is fetal hemoglobin is alkali resistant. In other words, it's going to maintain its pink color, all right? So if it stays pink after adding sodium hydroxide, it's fetal blood. But if it changes to a yellow color, that means it's maternal blood. I think the color it says in the book is yellow-brown. All right, so you add sodium hydroxide. If it stays pink, it's fetal blood. If it changes to yellow-brown, it's mom's blood. All right, guys, stay with me. We're close to being finished. All right, next page, 264, fecal enzymes. When you think about fecal enzymes, you just need to understand that if you have the appropriate enzymes in the stool, it means the body is producing the appropriate amount of enzymes to break down fats, okay? So there are certain, I've never did this test, but some of those enzymes that are produced from the pancreas, like trypsin and those different enzymes, you can test for those enzymes. Obviously, if those enzymes aren't in the stool, then it means they probably weren't being produced from the pancreas, right? Which means the patient is deficient in those enzymes. If they don't have the enzymes don't break down the fat, right? And so that could mean that it's just another confirmation to determine there's fats in the stools, probably something going on with the pancreas, right? It says enzymes supplied to the GI tract by the pancreas are essential for digesting proteins, carbs, and fats. Decreased production of these enzymes is associated with disorders such as chronic pancreatitis or cystic fibrosis. Steatorrhea occurs and undigested food appears in the feces. We know what those will look like. Analysis of the feces focuses primarily on proteolytic enzymes like trypsin, chymotrypsin, and elastase 1. I'm really not going to go into more detail than that about it. There are certain tests you can do for these enzymes. I actually think it's pretty interesting, this purple box at the bottom. Now this is a historical note, but if you read that purple box, it says what they used to do a long time ago to see if trypsin, for example, was in the stool, is they would like they would take stool specimen and lay it on top of x-ray film paper, okay? If you lay stool on the top of x-ray film paper, if that enzyme trypsin is in there, it'll cause a clearing. You guys know what x-ray paper looks like, right? When you see an x-ray of a leg or something, okay. If trypsin is in the stool, it's gonna take that black x-ray paper and kind of make it see-through, right? Because it's digesting the chemical that's in that x-ray paper, right? So that would let you know that the enzyme is present. If the enzyme is not present, that x-ray paper will stay that kind of a black color, right? That's like an old-timey way they used to test for it. I thought that was pretty interesting. I mean, I would assume that's pretty cheap to do it that way. All right, the last thing, carbohydrates. Says the presence of increased carbs in the stool produces osmotic diarrhea from the osmotic pressure of the unabsorbed sugar in the intestine, which will draw in fluid and electrolytes. Go down to about the last 5 lines in that paragraph. It says normal stool pH is between 7 and 8. However, if a person has increased use of carbs by intestinal bacteria, it will increase the lactic acid level and it will lower the stool pH to below 5.5 in cases of carbohydrate disorders. Now, you guys, you may not remember, but there's a test we can use to see if there's carbohydrates in the stool. And it's the same test that I showed you how to test for galactosuria in babies. It's the Clinny test. All right, that's what and how do you do this? I actually had to do this test about two different times when I worked. And I think that it's going to tell you had 1 part stool and I think 2 parts water. All right, and then you add one of those Clinny test tablets. And those Clinny test tablets are gonna bubble, okay? It's gonna bubble, and you look for the same color. Like if it goes to orange, it means that there's carbohydrates in the stool specimen, all right? So that's how you would test for carbohydrates. And it tells you that in your reading. You'll go down to the next paragraph. It says the copper reduction test is performed using the Clinny test tablet. This is going to take 1 part stool, emulsify it into 2 parts water, and then basically you just do the Clinny test. You add that pill, it's going to start bubbling, and it says Clinny test on stools can distinguish between diarrhea caused by abnormal excretion of reducing sugars and those caused by various viruses and parasites. What's that? I know, we're fixing to go for break, but I'm fixing to go sit there and instructor over there. They need to keep it down. review questions, you guys can still go with me on this. I got 1, 2, 3, 4, 5. I've got 6 test questions coming from these review questions. That's what I've got marked.
Yeah, because I don't think we've ever been that loud at 9 o'clock in the morning.
They didn't have that in those days. It wasn't a problem until she got loud. I asked you what you started to say.
Just get up and start banging on it. I mean, if you get up and start slapping that, they'll know. Just boom, 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 boom.
Okay, let's go through some of these questions real quick. Number 1, in what part of the digestive tract do pancreatic enzymes and bile salts contribute to digestion?
Small C?
Each one.
C, the
Small
small.
intestine. Good. Number 2, where does the reabsorption of water take place in the primary digestive process?
Large intestine.
Large intestine?
That was the first thing you told us to know.
What's that?
Looks at both A and C.
Oh. I mean, the majority of your reabsorption of water is going to take place in the large intestine. That's the one, remember, it can absorb up to 3 liters. This is a pretty good one. Number 3, which of the following tests is not performed to detect osmotic diarrhea?
A?
C.
Fecal.
Fecal neutrophils. Yeah, that's one that you gotta study on. Okay, what about number 4? The normal composition of feces includes all of the following except. We definitely have bacteria in the feces, right? Blood. Okay, now I realize that I just got through telling you just a minute or 2 ago that you can have a small amount of blood in the feces, but overall you're not really supposed to have blood in your feces, okay? That blood is coming from foods that you eat. Number 5, what's the fecal test that requires a 3-day specimen?
D. Quantitative.
Good, quantitative fecal fat, 72 hours. Number 6, the normal brown color of feces is produced by what?
D. Yeah, urobilin.
Urobilin, that's what gives the brown color of feces. Number 8, stools from people with steatorrhea will contain excess amounts of?
Fat.
Yeah, that's an easy one, right?
Yep.
Number 9, which of the following pairings of stool appearance and cause does not match?
D, B.
Yeah, B. B.
Pale and frothy could come from steatorrhea. I've got D marked down for that. Look back, yellow green. Does it say barium sulfate causes?
So they can make it
No,
yellow,
it's
not
dairy.
green.
Yeah.
Barium sulfate makes it pale yellow or white.
Alright, skip that one. Skip that one. That's not one of the ones I got marked anyway. Let's go to 28. A patient's stool exhibits increased fats, undigested muscle fibers, and the inability to digest gelatin. What condition would cause all of this? Cystic fibrosis. Remember, that's going to affect the pancreas, which could cause all of that. Number 23. What's the recommended number of samples that should be tested to confirm a negative occult blood result?
B. 2 samples.
B.
3 parts.
B. 2 samples taken from different parts of 3 stools. They tried to make that confusing. I wouldn't do it that way with the test. I would just say 3 different stool samples and you gotta take it from 2 different spots on each sample, okay? Number 29. Okay, I don't expect you to know this just yet, but 29, the answer is C, and you need to know it. A stool specimen collected from an infant with diarrhea has a pH of 5. This result correlates with a positive clinic test. Remember me telling you about carbohydrates in the stool? Okay, you can detect that by doing the clinic test, and if there's excess carbohydrates in the stool, it also causes the pH of the stool to go down. It becomes more acidic. Number 30, which of the following tests differentiates a malabsorption cause from a maldigestion cause? It's steatorrhea.
B.
The D-xylose test. Good. All right, let's take 10 or 15 minutes, come back, I'll give you a review for the final. I probably will not